So far we have been talking about the motivation behind blockchains, we have been talking about the decentralized ledger. In this lecture we are going to talk about the most crucial and maybe the most complicated part of blockchains, the so-called mining operation. So miners play an extremely crucial role in the blockchain ecosystem. In a centralized network, the trusted third parties verify all the transactions. And of course a good question is how to achieve the same features with decentralized networks when we know that there are no trusted third parties. And of course the answer has something to do with miners. Okay, so mining is essentially the most important concept in blockchain as well as in cryptocurrencies such as Bitcoin. So the problem is that when we are dealing with centralized networks such as trusted third parties, for example banks, we know for certain that whenever we send money to a given client, then the bank is going to verify the transactions, it is going to handle everything. And by the way, under the hood, it is rather complicated because the bank has to verify the sender, the bank has to verify the receiver with the help of identification cards and so on. The bank will verify that the sender is able to send the given amount and the receiver is able to get the given amount. And of course, in the centralized ledger or in the central database, it will update the balance accordingly. So it is relatively easy to understand that how to solve this problem if we have a centralized system, a centralized ledger, the database itself. But of course, in a decentralized system, who will handle the transactions? And of course, the answer is that miners will handle and verify the transactions. We have been talking about the immutable ledger, and we came to the conclusion that whenever the client sends money to another client, then essentially a new block will be appended to the blockchain, and of course the network will broadcast that the blockchain has been updated and the blockchains will be updated accordingly. And it is absolutely crucial that the blocks are not going to be created by the users in the network. Of course, these blocks will be created and will be verified by the miners. Okay, so miners will handle and verify the transactions. They will consider a given transaction. They will check whether is it possible to execute the given transaction. It will verify the sender and the receiver. So essentially, miners will do approximately the same as we have seen with the trusted third party. And by the way, it is crucial that getting paid is not the aim of mining. It is just the byproduct. So the aim of mining is to handle and verify the transactions. Getting paid is just the byproduct. So mining is the mechanism that allows the blockchain to have a decentralized security. So we will come to the conclusion in the coming lectures that miners will provide decentralized security. Mining is about finding the right hash values for the blocks and adding these blocks to the blockchain. And of course, these operations will be executed by the miners. So this is what we have been talking about in the previous lectures, that a blockchain is essentially a linked list where the pointers are cryptographic hashes, so-called hash pointers. So for example, if we are dealing with the third block in the blockchain, the previous hash is pointing to the actual hash in the previous block. This is how we can end up with a linked list where the pointers are cryptographic hashes. And of course, it is absolutely crucial that these hashes are calculated by the miners. So the miners will verify the transaction within a given block and they will generate the underlying hash values, and of course they will append the given block to the underlying blockchain. By the way, it is crucial that the data can be anything. It can be health related data such as blood pressure, blood sugar and so on if we are dealing with a healthcare related blockchain. If we are dealing with a cryptocurrency, then of course the data has something to do with transactions, but we are going to talk about several blockchain technologies in the last chapter of this course, and we will come to the conclusion that we can store whatever we want in the underlying blockchain. Because of course the most popular application of blockchains has something to do with cryptocurrencies. This is why we assume that the data is a single transaction or multiple transactions. Okay, so miners of the blockchain network find the valid hash values for the blocks, they verify the transactions and so on, and mining is a computational heavy operation. We will talk about why is it so crucial to make sure that mining is computationally heavy. We will come to the conclusion that this is how we can make sure that the underlying decentralized network will be secure. Okay, so let's talk about the hashes. So we have discussed in one of the previous lecture that, for example, Bitcoin is dealing with the SHA-256 algorithm. What does it mean? That the output is a 256 bits long binary hash. Binary in the sense that the values can be 0 or 1 and there are 256 bits, which means of course that the total number of hashes is equals to 2 to the power of 256. 2 because there are two possible values, 0 or 1, and of course 256 because there are 256 bits altogether. By the way, usually we are representing hashes in a hexadecimal format, which means that instead of dealing with two values, 0 and 1, we are dealing with 16 values, the integers from 0 to 9, and of course we have some additional characters A, B, C, D, E, and F. So altogether we are dealing with 16 possible values, and of course this is why if we represent the 256 bits long hash in hexadecimal, then there will be 64 hexadecimal characters, and of course the total number of hashes is equals to 16 to the power of 64, which is of course the same as 2 to the power of 256, because this is the same hash but in a different representation. Usually we prefer hexadecimal because we just have to use 64 characters instead of 256. So the first hash is 0000, so contains all zeros. The second hash is 000 and we have a 1 at the end. Then of course we have 000 and we have a 2 at the end of the hash. And of course the last possible hash contains all F values. So there is 2 to the power of 256 possible hash values. So during the mining operation, the miners will generate a hash for a given block with the help of the SHA-256 algorithm. What's crucial that mining has an important parameter in the Bitcoin ecosystem. It is called difficulty and it is characterized by leading zeros. We are going to talk about it in the next lecture. What's crucial that we will make sure that the mining operation will be very hard and very expensive. We are going to talk about why. What's crucial that the aim of mining is to generate hashes, but there is some constraints, which means that most of the generated SHA-256 hashes are not allowed. So the difficulty of mining is defined by the leading zeros, and we have to make sure that the mining operation is quite hard. This is how we can make sure that the underlying blockchain ecosystem will as secure as possible. In the next lectures, we are going to talk about why to use leading zeros and why to make the mining operation difficult. Thanks for watching.